Here we're asked to find an equation in just the variables x and y for the curve defined by x equals root t, y equals 2t minus 1 when t is greater than or equal to 0. So we have parametric equations here. They would trace out some curve in the plane. We're being asked for an equation that just involves x and y. So what we're going to do here is what's called eliminating the parameter. And one way of doing that is to look at the equations we have and, well, solving for t and substituting it into the other equation. So for this one, if I look at this equation, I have x equals root t, which means that t is equal to x squared. All right, I can substitute that into the other equation. I get 2x squared minus 1. Now, there was a restriction here that t was greater than or equal to 0, which means x is greater than or equal to 0. Well, if t is positive, right, and plug positive things under that square root or 0, then x is also going to be only positive. T is defined here, x is defined here by something that has to be positive or 0 itself. So I'll add that in here, that this is only true if x is greater than or equal to 0. But I found a rectangular equation that I could graph with the restriction that x is always greater than or equal to 0, so only half of the parabola. All right, well, I have a feeling a number of folks watching the video says, well, that's nice. You solved for t in the x equation. What happens if you do it in the y equation? Well, let's see, I get y plus 1 equals 2t, and t is equal to y plus 1 divided by 2. Substitute that into the other equation, and y is equal to y plus 1 all over 2. And that is also an equation that works. I could actually imagine solving this for x, and we get that same equation. So those are equivalent solutions. Well, that's it for now.